Hello viewers, welcome back to today's class. We are going to today be discussing joint variation. We've discussed variation where we introduced variation. I have discussed direct variation. I've discussed inverse variation. I have also discussed partial variation. Let's look at joint variation. This is actually where most times questions come from, where they combine variations. Joint variation is simply the combination of two or more of these variations. Direct, inverse, just a combination, more than one variation, when one variable is related to more than one other variable. So we are going to look at how that is done. This question said, it's a Waec question, x, y, and z are related such that x varies directly as the cube of y. You remember how we represent our variation? We say x varies directly as the cube of y, okay, and inversely as the square of z. The same x varies inversely as the square of z. Okay, this is how we represent inverse variation. This is how we represent direct variation. So the same s varies directly as y cube and inversely as z squared. So if we put them together, this is going to be that x is proportional to y cube all over z squared, because this one is inverse. So this is what we have, and then whatever comes is after we've interpreted this. So remember the same process. If we change this proportionality sign to an equality sign, we introduce a constant, and then we have y cube all over z squared. So this is the relationship between the variables that we are going to use to solve any question. So what do we do? And then they said, if x is 108, so we begin to substitute here. X is 108, this is x, equals k times y is 3, so we are going to have 3 raised to power 3, because y is raised to power 3, all over z squared. Yz is 4, so we are going to have 4 raised to power 2. So we solve this now and then get the value of k as we used to do. Then substitute that k here and then solve other questions that are going to be given under that. So what do we do? 108 is equal to, if we simplify, k times 3 raised to power 3 is 27, all over 4 raised to power 2 is 16. Okay, and then this is all over 1. Remember, we are looking for k, so we can cross multiply here to have k times 27 times 1. You have 27k equals 108 times 16. Okay, then to find k, we divide both sides of the equation by 27. Divide by 27. This 27 will cancel this 27, and k will be equal to what? 27 into 108 will give us 4. Will give us 4. Then 4 times 16, we have 64. So our k is 64. That is what k is. Then what do? We substitute here to get the equation connecting x, y, and z. So that's what we are going to do. We substitute to get the equation connecting x, y, and z. I'm going to clean this part of the board so that we'll do that here. So we have x equals k is 64. We have 64 y cube all over z squared. So this is the equation now connecting x, y, and z. Then the further question said, find z when x is 4,000 and y is 10. We simply substitute here. X is 4,000. 4,000 equals 64 times y is 10. So we have 10 raised to power 3 all over z squared. So we now have to solve to get z. So that's what we're going to do. So what do we do now? 4,000, we have 4,000 equals 64 times 10 raised to the power 3 is 1000. So we're going to have 64,000 all over z squared. This is over 1. Then we do cross multiply. We do cross multiplication so that we have z squared times this. We have 4,000 z squared equals 1 times 64,000. We have 64,000. Then we divide both sides by 4,000. Divide both sides of the equation by 4,000. So this 4,000 will cancel this 4,000. And then, of course, these 3 zeros will cancel these 3 zeros. 64 divided by 4 will give us 16. So z squared is 16. And that implies that z equals the square root of 16 and z equals 4. As simple as that. So that is how we solve joint variation. It's the same as direct and inverse, only that we have more than one variable here that is related to the principal variable. So let's look at one more question. If x is proportional to y, z raised to the power 1 over 3, and y is proportional to z raised to the power minus 2, show that x is proportional to y raised to the power 5 over 6. Whenever you're solving mathematics and you are asked to show that, it means use what you are given to get what you are asked to show. So we are going to use this and this to arrive at this. Okay? Solution. We have x to be proportional to y, z 1 over 3. And the second one, we have y to be proportional to z minus 2. Then we want to get a relationship between x and y. You see here that there is a relationship between x and y here anyway, but there is z. So how do we remove this z so that it becomes just x and y? By trying to get the relationship between this y and z to replace this z with y, so that we just have y here. So you remember that this is, if we change this to equality sign, we are going to have k y z raised to the power 1 over 3. Sorry. And then if we change this also to equality sign, we have y equals k z raised to the power minus 2. Okay? If this is relationship between y and z, we want to replace this z. So we are going to make z sort of the formula here, so that we will substitute it here and eliminate z. Okay? Okay. So that is what we are going to do. If we try to make z sort of the formula here, we are going to have z here raised to the power minus 2 to be equal to y over k. If we divide both sides by k, we'll have this. Okay? And you know that this thing is 1 over z raised to the power 2 equal to y over k. Okay? And then, remember, we want to make z sort of the formula. So if we cross multiply, we have z squared y equals k. And we divide both sides by y, so that we have what? Z squared equals k over y. Therefore, z will be equal to the square root of k over y. To remove this square, you find the square root of both sides. So z is square root of k over y. So if we substitute that here, we are going to have x equals what? K y, then z is square root of k over y raised to the power 1 over 3. Okay? Remember, this is k is a constant. Even if you find the square root, it's still a constant. So we can put them together to just be one constant. So x is equal to, we'll remove this constant and join it with this to have k, y, then we have 1 all over root y. Because we have removed the root k to join this k. They are all constants. Raised to the power 1 over 3. Okay? And we know that x will now be equal to ky into, this simply means y raised to the power minus 1 over 2. Because square root of y means y raised to the power 1 over 2. And because it's a reciprocal, then we have minus 1 over 2 raised to the power 1 over 3. Okay? If we put this together, we are going to have x equals ky into y raised to power, we multiply this, minus 1 all over 6. Okay, then we'll proceed here. X equals this, so x equals k is still there. This y can be written as y raised to power 1, while this one is y raised to power minus 1 over 6. And because the bases are the same, we can add the powers, the law of indices. So x equals k, y raised to power 1 minus 1 over 6. And that x equals k, 1 minus 1 over 6 will give us 5 over 6. And this is what we have here. Therefore, we can see that x is proportional to y raised to power 5 over 6 as instructed. You see how that is done? We have this and this. We used it to get this. By making z subject to the formula here and substituting it in place of z here, because when we make z subject to the formula, we now have just y. And when we substitute it here, it means it's only y that will remain here. So that we have the relationship between x and just y as we have it this place. So that is how joint variation can come in different forms. See you next time.